Welcome to Everest Tutoring's Quantitative Reasoning Sample Exam Walkthrough.
Today we'll be going through the Quantitative Reasoning sample test for GATE at Everest Tutoring. So starting off, we need to write our full name, right? So we're Everest Tutoring. All right, let's begin. So Jens has large paper clips and small paper clips. He is weighing them using kitchen scales. 3 large paper clips and 1 small paper clip weigh 10 grams. Jen removes one of the large paper clips. The remaining paper clips weigh 2 grams, 7.2 grams. So let's see. We have 3 large here and 1 small, right? And then these, when we add them all up and we weigh it, it becomes 10 grams. Then on the other side, we have 2 large, 1 small, and then the weight decreases all the way to 7.2 grams. So let's see, what's the difference when we go from this one to this one? The difference is that we removed 1 large paper clip. And see how the weight dropped from 10 grams to 7.2 grams? The weight dropped by what? If we do 10 minus 7.2, the weight dropped by 2.8 grams. This means that when we removed 1 large paper clip, we lost 2.8 grams. Therefore, the large paperclip must weigh 2.8 grams, right? So 1 large paperclip must weigh 2.8 grams. Now let's think. So 2 large plus 1 small equals 7.2. Here at Everest, we will teach you algebra. So when we teach algebra, we realize that you can substitute things. That means instead of a large paperclip, we can just write what it weighs. That means we do 2 times 2.8, right? Because we have 2 large paper clips. So instead of writing a large paper clip, we can write the weight. So 2 times large, 2 times 2 times 2.8 plus the 1 small equals 7.2. So we need to isolate so we get the 1 small paper clip by itself. So that means 1 small paper clip plus 5.6 is equal to 7.2 grams, right? So to get 1 small paperclip by itself, we need to do something to both sides so that this 5.6 gets rid of. Let's think, what can we do? What we do is we subtract 5.6 from both sides. So then we do 1 small paperclip plus 0 is equal to 1.6 grams. So that means 1 small paperclip is 1.6 grams. Let's see, that means our first answer is B. Let's continue. Lucky packs. Cards for a trading card game can usually be purchased in packs of 10. These packs cost $6 each. As part of a special offer, the packs contain 2 extra cards for no extra cost. What is the difference in the price per card between the packs of 10 and the packs of 12? Let's look. So you can buy them in packs of 10. Okay, and the packs cost $6 each, right? So that means for $6, you buy 10 cards. So if we spend $6, we get 10 cards, right? So this means that to find the number, how much 1 card costs, we do $6 divide 10. When we do this, we see how much does each card cost. So $6 is 600 cents. So we have 10 and we divide it by 10. So that means each card is 60 cents. What happens if we had packs of 12? That means $6, because think about it, we get 2 extra cards for no extra cost. That means $6 gets us 12 cards, right? So if to find the price of 1 card in a 10 pack, we did $6 divide 10. To find it in a 12 pack, we do $6 divided by 12, right? $6 is 600 cents, and we divide that by 12. So in the end, we get 50 cents per card. That means the difference is 60 minus 50. So our second answer is A. Pizza versus sushi. In Miss Piazza's class, 16 students study Japanese and 8 study Italian. The students made the following pie graphs. Okay? What is the correct graph for the whole class? So 16 students study Japanese and 18 students study Italian. 16 study Japanese, 8 students study Italian. So let's look. The number of students studying Japanese. So we have 16 total students, right? I'll use different colors to show Japanese versus Italian. So we have 16 students who do Japanese, who study. Of the students who study Japanese, let's see. See how this is split up into quarters? That means the people who prefer pizza are 1/4 of the total. Do you understand why? A pie chart represents it represents everybody, right? And we can see that pizza represents 1/4 of the pie chart. So thus, pizza is 1/4 of it, which means sushi is the remaining, right? What's the remaining? If pizza represents 1/4, the remaining would be 3/4. So if 16 students study Japanese, a quarter of them will have pizza. What's a quarter of 16? That means we'll have 4 people who like pizza, and the remaining will like sushi. So 12 will like sushi. Now let's look at the other. So we have 8 people who study Italian. People who study Italian, 1/4 like sushi, right? Because see how the pie chart represents it's 1/4? So that means a quarter like sushi, and the remaining, which is 3/4, like pizza. 1/4 like sushi and 3/4 like pizza. So if 8 study Italian, a quarter of the 8 will like sushi. That means 2 students will like sushi, and the remaining will like pizza. So 6 will like pizza. So let's look at the total class. In the total class, we have 6 plus 4, 10 people who like pizza, right? And then we have 2 plus 12, 14 people who like sushi, right? So our total number of students is 24 students. Let's see, pizza is 10 over 24. Pizza represents 2/7, right? So that means we need to find the one where pizza is 2/7 and sushi is the remaining 5/7. If we look at it, we can see that in this one, pizza is half, Japanese sushi is half, which means it can't be option B. In this one, there are more people who like pizza than sushi, so it can't be this. So in this one, the pizza is 2/7, right? That's far away from being a half. See how close the pizza is to being 1/2 of the pie chart? It just needs this little area, right? But pizza is 2/7 of the class, which means we can eliminate this answer. So all that's left through our process of elimination is option A. Let's continue. For the class party, Miss Piazza buys pizza for half the class and sushi for half the class. How many students cannot receive their preferred food? So she buys pizza for half the class. We had 24 students. That means 12 people. That means she buy 12 pizzas, 12 sushi. But 14 people like sushi and 10 people like pizza. That means, let's see, if there's 12 sushi available but 14 people want it, how many people? 2 people can't get the food they want. 2 people can't get sushi, right? 2 people can't get sushi. Then, how many students cannot receive their preferred food? It's just 2. Let's continue. So, 3 gears are shown below. When any one gear is turned, the other 2 also turn. The gears only turn in the directions shown by the arrows. Each gear has numbers printed on it. As the gears turn, a different number appears inside the circular window in the front of each gear. So that means you see how there are arrows here? So the gears will turn, right? So you'll go from 1 to 2 to 3. As like the gears turn, right? The numbers will go towards there. I hope everyone understands what the question is asking for. Okay. In the starting position, each gear is number 1 in its window. We can see that, right? Number 1, number 1, number 1. When gear A, so this is gear A, this is a helpful tip. Always underline what the question is talking about. So as soon as you see the word gear A, highlight gear A. After gear A makes one full turn, gears B and C show number 8 in each of their windows. From the starting position, gear 8 makes 3 full turns. What numbers do gears B and C show? So let's see. Gear A to go all the way back is 1, 2, 3, 4, 5, 6, 7. Sorry. So we go 1. Imagine in your head, we're moving this way. So we go 1. So we have to see how many turns to get all the way back, right? 1, then 2, right? Then 3, then 4, then 5, then 6, then 7. We need 7 to get all the way back, right? So that means gear 8 makes 3 full turns. That means we've made 21 turns, right? Let's see. To go gear B repeats itself how many times? Let's see. So since it's going this way, the next number will be 2, then 3, 2, then 3, then 4, 5, 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So gear B repeats itself every 10 times. So if we do 21 turns, it will repeat itself twice, right? 21 divide 10, it will repeat itself twice, but there'll be one remainder, which means it will come back to 1 twice, because it will rotate around fully, and then it will be the next number. So it will be 2. Gear B will show 2. That means option C and option D can be eliminated, right? Gear B will show 2. Let's look at gear C. Gear C goes this way, right? We're going this way. So let's see how many turns does it take to go back to number 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. It takes 9 turns. So if we have 21 and we do divide 9, we have 2 remainder 3. That means it'll go around the entire block twice, but there'll be a remainder of 3. That means it'll be the third number. So 1, 2, 3. It shows number 4. That means gear C will show 4. So it can't be B. It has to be, it can't be A. It has to be B. From the starting position, gear A is turned so that gear C completes 1 full turn. What number does gear A now show in its window? Gear C, let's see. Gear C required 9 turns to go back, right? That's 1 full turn. 1 full turn means 9 times it goes around. So gear A is turned 9 times. Let's see. Gear A repeats itself every 7 times, right? That's what we learned from the very beginning. There are 7 lines. So if we do 9 divide 7, we get 1 remainder 2. That means it did 1 full round about the circle, and then there's a remainder of 2, which means it's going to be 1, 2. It'll be number 3. That'll be the number it shows. After 10 full turns of gear A from the starting position, what number does gear B show in its window? After 10 full turns of gear A from the starting position, what number does gear B show in its window? Alright, let's see. 10 full turns, so gear A's 1 full turns means 7 small turns. So that means 10 full turns is 70 small turns, pretty much. 70 small turns. Gear B repeats itself every 10 turns. That means gear B, if we do 7, divide by 10, it will do 7 full turns. And if it starts at 1, it will just end up right back at 1 because it went around the block 7 times. Then, how many full turns of gear A from the starting position are needed for all 3 gears to return back? So, gear A repeats itself every 7 turns. Gear B every 10 turns. Gear C every 9 turns. Okay? So let's see. 7, we need to find the lowest common multiple of these 3. Everyone understand why? Because think, it has to be a lowest common multiple because the number that we get has to divide all 3 numbers into a whole number. If there's a remainder, that means it's not a full turn and that it won't be the starting position, right? Like, for example, if I do 9 turns, right, even though option C will go back to the normal, option B will not go back to normal, and option A will not go back to normal because it's not evenly divided, right? So let's think. The best way to find the lowest common multiple is times the numbers together. So we do 70 times, so 7 times 10 times 9, which is 70 times 9, which is 630. Okay? Let's see. We can also try to put in every solution. 7 would make A go back to normal. But B and C won't go back because it won't be a whole number if you do 10 divided by 7. 26, that will not work for any of them. 260, it will only work for 10. So by process of elimination, it must be 630, as A, B, and C all can't work. A zoo has 6 animals, each of different species. The zoo has a number of displays that can each hold up to 5 animals. The cross symbol indicates animals that cannot be displayed together. Which one of the following is a group of animals that can be displayed together? Let's see. So, this is a boar, right? The boar cannot go with the koala. That means option A is gone. Immediately option A is gone. Because you see, this symbol indicates they can't be together. Imagine they'll start fighting straight up, right? This means the boar and the koalas can never be together. All right, now let's look. The boar and the giraffe. Boar and giraffe, that works. Okay. Boar and meerkat. The boar and meerkat can live together. Then the giraffe and meerkat cannot live together. See? That means the giraffes and meerkats can't live together, so this group can't live together. Let's look. Koala. Can koalas live with cows? They can. Can koalas live with giraffes? They can. Can cows live with giraffes? Cows, giraffes? No. Cows cannot live with giraffes. That means this group can't live because the cows and giraffes will start fighting. That means by process of elimination, the last one has to be right. But for sake of completion, let's go through it. The koala and cow cannot. Can the koala and cow live together? They can. Can the koala and meerkat live together? They can. Can the cow and meerkat live together? Let's see. Cow, meerkat, they can. Hence, D has to be the right answer. In the equation below, hashtag always represents the same mathematical sequence. This mathematical sequence is made up of one of the basic operators, followed by a positive whole number, followed by another basic operator. For example, 3 hashtag 2 equals 4, and 4 hashtag 1 equals 7. So they're basically saying hashtag equals plus or minus or times or divide a positive whole number, for example, maybe 2, and then followed by another basic operator. For example, so hashtag, we have these 4 basic operators, and it has to be a real number, then this. We just have to go through every single possible answer right now, okay? Let's go through all the options. So 3, maybe 3 times 2 minus 2 equals 4, right? That could be our hashtag, because 3 times 2 equals 6, minus 2 equals 4. So right now, I think my hashtag is times 2 minus 2. So let's look. 4 hashtag 1 equals 4 times 2 minus 2, which is 8 minus, sorry. The hashtag is times 2 minus, right? Because it doesn't followed by another, the basic operator at the end is not followed by another number. So 4 hashtag 1 equals 4 times 2 minus 1, which is 8 minus 1, which is 7. Hence, our hashtag equals this. Let's try 3 hashtag 2 hashtag 1. If we follow BODMAS or BIMDAS, brackets is our first order we look at. So we have to look at 2 hashtag 1. 2 hashtag 1 is 2 times 2 minus 1, which is 3. So now we have 3 hashtag 3, which is 3 times 2 minus 3, which is 3. Hence, our answer is 3. Let's continue. So 4 hashtag 1, let's see, 4 hashtag 1 equals 4 times 2 minus 1, which is 7. 7 hashtag something equals 9. Let's see. Let's let this something equal x, right? So 7 times 2 minus x equals 9, right? That means 14 minus x equals 9. We need to isolate, right? Let's subtract 14 from both sides. We get minus x plus 14 minus 14 equals 9 minus 14. That means minus x equals minus 5. If we take away the minus from each side, we get x equals 5. Okay? That means 5 hashtag a number equals 5, right? Because we realize this bracket has to equal 5 because this bracket equals 7 and this is 7 hashtag this bracket, right? So that means 7 hashtag whatever this is has to equal 9. And we realize this equals 5. So that means 5 hashtag something equals 5. So let's see. 5 times 2 minus, let's call this y. 5 times 2 minus y equals 5. That means 10 minus y equals 5. 10 minus what equals 5, right? Let's get rid of 10 from both sides. We get 5 minus 10, which is minus 5. Get rid of the minus from both sides, you get 5. So we realize this unknown square has to be 5. Finn has downloaded 3 types of music tracks, R&B, EDM, and K-pop from 3 online stores, iTunes, Spotify, and generic tracks. The figure indicates the distribution of his downloads. For example, half of his tracks come from iTunes and 1/4 of these were R&B. Alright, let's look. So half of it comes from iTunes. It's like a flow chart, right? Or a tree diagram. Let's see, if Finn downloaded 6 EDM tracks from iTunes, let's see, 6 EDM tracks. 6 EDM tracks. 6 is a quarter of what he got from iTunes, right? If 6 is a quarter of what he got at iTunes, that means iTunes must be 6 times 4. That means he bought 24 tracks at iTunes. Because if he bought 6 tracks of EDM at iTunes and EDM is a quarter of iTunes is 6 times 4, so 24. Then if iTunes is half of Finn's downloads, that means Finn's downloads has to be 24 times 2. So Finn has downloaded in total 48 tracks, right? If he's downloaded 48 tracks and a third of the is generic tracks, that means 48 divided 3. This is how many generic tracks he downloaded. And if he downloaded 1/8 of generic tracks for K-pop, that means 16 divided 8. This is the number of K-pop tracks he bought from generic tracks. If Finn downloaded a total of 24 tracks from Spotify, how many tracks did he download from iTunes? So if he downloaded 24 from Spotify and 24 represents 1/6, that means his total downloaded was 144. And if half of them went to iTunes, that means half of 144, which is 72, went to iTunes. Metals can be ranked on a scale of reactivity. JAR uses a special meter that compares one metal to another. The meter measures the differences in reactivity between the two metals. JAR compared several different metals. The results are shown in the table. For example, magnesium is 55 units more reactive than zinc, and aluminium is 31 units less reactive than zinc. Right? Let's think. So magnesium 86 more units than aluminium. Aluminium 86 more units than magnesium. That's why the difference is minus 86, right? Let's see, magnesium is 55 more than zinc, okay? Which of the following metals has the lowest reactivities? Let's see. So right now, magnesium and aluminium has the biggest difference. Aluminium is aluminium more reactive than anything? Aluminium is more reactive than zinc, but you see how zinc is never on the first metal side? That means let's look. So magnesium is more reactive than aluminium. So right now, aluminium could be our lowest reactivity metal, right? Then we look at this. Aluminium is still less reactive than zinc because it's a negative difference. That means aluminium is still our least reactive thing, right? Okay. Then let's see. Any other mention of aluminium? Aluminium is less reactive than magnesium as well. Okay. Let's draw out a number line so we can see the difference. So we'll do from the left-hand side is the most reactive. So right now it's magnesium and aluminium. So there's an 86 difference, right? Copper and gold have a 44 difference, but we don't know what copper or gold is. Lead is less reactive than magnesium by 111. Aluminium is less reactive by 86, right? But magnesium is 111 more reactive than lead. So lead is all the way over here, right? Then let's see. Gold is less reactive than lead by 71. So if we go another 71, we get to gold. Okay? Then let's see. Gold is less reactive than copper. So right now, it probably is gold is our least reactive metal. So there we go. Which of the following reactivities has a reactivity between the reactivities of aluminium and copper? Let's see. Copper is 44 more reactive than gold. That means it's 44 here. But you see how copper is 44 more attractive than more reactive, but 44 is smaller than 71. That means lead is more reactive than copper because the difference between lead and gold is bigger than the difference between copper and gold. That means copper should be here. So the metal in between aluminium and copper is going to be lead. What would the meter show if the first metal is gold and the second is aluminium? Let's see. 86 to 111 to get to lead, and then another 71 to get to gold. That means in total, from aluminium to gold, you have to do 111 plus 71, which is 182. So if the meter read first metal as gold and second as magnesium, right? Let's think. Magnesium is 182 more than gold. So magnesium, 182 gold. But if gold is written as the first one, gold is 182 less than magnesium. See, this is a trick question. They have written gold as the first metal. This means that it's minus 182, as gold is like this. Gold is less than and minus 182 of magnesium. All right, continuing. So, some computerized systems have become very good at recognizing human emotions by analyzing facial expressions and voice patterns. In a series of tests, a system analyzed videos of people sneaking when they were angry, sad, happy, or showed no emotion, neutral. After each video, the system classified the emotion shown. In the first test, the system analyzed only the voice from the videos. In the second test, it analyzed only the face. In the final test, the system analyzed the voice and the face combined. The tables show the results of the test. For example, when videos were shown but only the voice was analyzed, the system mistakenly classified 22% of angry people as being happy. Okay. All right, let's look. See, when their actual emotion is anger, right? But the classified emotion is basically when they did the analysis, the computer gave the person that emotion. They think that human in the video is happy. See how when they're actually facing anger, 22% actually became happy, which means 22% were classified incorrectly. That's what the entire prompt is about. It's basically saying this character, let's call him Joe. Joe is very angry right now, right? He's very angry. But the video, I mean, the voice, if we look at the voice made Joe think, the voice thought Joe was happy, right? So then they would place Joe here, but that's a mistake. Joe isn't happy, Joe is angry. So that's what this table is trying to show us. It's trying to show us 68% were classified correctly, 65% of sad people classified as sad, 70% of happy people were classified as happy, and 81% of neutral were classified as neutral. Right? For voice only analysis, which emotion was the hardest to classify correctly? So 68% were classified correctly for anger, which means 32% were classified incorrectly. If 65% were classified correctly, for sadness, 35 was classified incorrectly. If 70 were classified correctly, that means 30 was classified incorrectly. If 81 was classified correctly, 19 were classified incorrectly. You see how sadness has the highest amount of classified incorrectly? That means it must be our hardest emotion to measure. Considering just the first two tests, which of the following is most likely? Mistaking an angry face for a sad face. Let's look. Is mistaking an angry face for a sad face. So this is an actual angry face, right? And then we say that we misclassify them as sad. That's 18%. Let's look. Mistaking a sad face for an angry face. So sad is here. If we mistake them as angry, it's 6%. That means most likely means which is the highest probability, which means B already can't be right. Then let's look. Mistaking an angry voice for a sad voice. Angry voice is here. Sad is here. That means 5% of the people who are angry were misclassified as sad. See how this is so low? This is gone as well, because most likely means highest probability. Mistaking a sad voice for an angry voice. Sad is here. Mistaking is angry. You get 7%. That means by clearly 18% is the highest. So this is our answer. How many emotions have a greater chance of being correctly classified by face-only analysis than by combined analysis? Let's look. How many faces have a greater chance of being correctly classified by face rather than combined? Let's look. So face classified 79% as correct for anger, 81% correct for sadness, 100% for happiness, 81% for neutral. If you combined, 94% of angry people were correct, 79% of sadness, right? See how this was 81, this was 79? That means there's already one emotion where the face-only analysis is better than the combined analysis. Then let's look. In happiness, happiness is 100 here, 90 here. That means there's a second emotion that is better. Neutral is 81 and 92 here, which means that the combined analysis is better. Still, two emotions were classified better by the face than the combined. So our answer is 2. Antonia places 9 identical discs in a 3x3 grid. One side of each disc is black and the other side is white. Antonia selects one disc at a time and turns it over. All the neighboring discs above, below, left, right are also turned over. For example, when the disc indicated by X is selected and turned over, the 3 neighboring discs are turned over. See how this becomes white, this becomes white, this becomes black, this becomes black. It's basically we invert the colors. Which disc changes these to these? Let's think. So, which colors are changing? These two colors changed, and then this colors changed. So these two colors changed, right? And remember how when it's X, it does this in any shape around it, right? In this kind of thing. So if in order for these 3 colors to be the ones that change, right? Because they did, right? See how black became white, white became black, and white became black here. This means this has to be our X. Because if this was our X, this would change color, this would change color, and the X1 would change color. So that means our answer is the one with X in the bottom right, so D. Antonia selects every disc once. How many times is the center disc turned over? If she selects the center disc, if she selects every disc once, right? That means when it's this, let's look, when is the top right hand one? When is the top right hand one? This disc will change, this disc will change. So that means the top right one won't change it. If this, that means this one will change, this one will change, this one will change. So we have 1, right? If this one is selected, this one will change, this one will change. So the center doesn't change. If this is selected, this center does change. So this is 2. If the center is selected, the center one will change. If this dot is selected, the center one will change along with others. So that means there's another one that changes. Then let's look. If we select this one, only these 2 will change. So that doesn't count. If you select this one will change, this one will change, this one will change. So the center disc does change. If we select this one, if we select this one will change, this one will change, but the center dot remains unchanged. That means there are 5 times when the center disc will change. Alright, Antonia starts with this. She selects the disc, boom, boom, boom. Okay, so let's see. If she starts with this and she selects this, let's draw out our circles, right? That means this will change color, this will change color, this will change color. Alright, then the next one, this is step 2. Step 2, this one will change color, this one will change. All these ones will change color, right? That means this becomes white, this becomes black, this becomes black, this goes back to white, this goes back to white, okay? Then finally, this one changes, which means this one changes, this one changes. Let's draw it out. That means this one will become black, this one's white, this one will become black, this one will be white. Let's see, which one looks like this? It looks like option D. The maps below show information about the number of people in a country who watch the TV show Super Chef. Map 1 shows the number of people in each state in the country. Map 2 shows the percentage of people in each state who watch Super Chef. Alright. So, when it has the number in a circle, it's saying there are 5 million people. So that means 6 in a circle means 6 million. It's basically saying how many million people live in that state. In state 5, there are 6 million. In state 6, there are 5 million. In state 1, there are 5 million. Like that, and so on. Then see, the number inside this little oblong would be the percentage of the population who watch Super Chef. So how many more people watch Super Chef in state 2 than state 6? State 2, we have how many people? State 2, we have 4 million people. 4 million people, and let's look. State 2 is this one. 50% of state 2 watches Super Chef. That means 2 million in state 2 watch Super Chef. Then let's look at state 6. State 6 has 5 million people. State 6 has 5 million people, and state 6 is this one. It's saying 1/5 or 20% of state 6 watches Super Chef. If state 6 has 5 million people, 1/5 of 5 million is 1 million. That means 1 million people watch it in state 6. That means 1 million more people watch it in state 2 than state 6. So, with question 24, we see there is how many people watch Super Chef in the entire country. That means we need to add up every single state. We need to add up the number of people who watch Super Chef in every single state. Right, let's start off with state 1. State 1 has 5 million people. 10% of state 1, see this area state 1, 10% of state 1 watch Super Chef. That means it's 10% of 5 million. So 0.5 million from state 1. Then look at state 2. State 2 has 4 million. State 2 has 4 million. And 4 million is 50%. 50% of the 4 million watch Super Chef. That means 2 million watch it here. Then we have state 3. State 3 has 10 million and 10% of them watch Super Chef. That means 1 million must watch it. Then we have state 4. State 4 is 20 million. 10% of 20 million is 2 million. State 5 is 6 million. 20% of state 5 has 20% of state 5, which is Super Chef. So that means it's 6 million times 0.2, which is just the same as 6 divided by 5. So 1.2 million. Then we have state 6. In state 6, 20% of the 5 million watch Super Chef. That means we have to divide it by 5 since it's 20%, so 1 million. So if we add this all up, we get 1 plus 2 plus 1 plus 2 plus 1.2 plus 0.5, which is 3 plus 3 plus 1.7, which is 6 plus 1.7, which is 7.7 million, which is option B. Continuing, the number of people who do not watch Super Chef in state 6 is twice as many as the number who watch Super Chef in. So let's look. It's asking about state 6, right? In state 6, 20% of state 6 watch Super Chef, so 1 million watch Super Chef. 4 million do not watch Super Chef. 4 million do not watch Super Chef, and this is twice as many as the number who watch Super Chef in another state. That means we don't know, in some mystery state, 2 million people watch Super Chef. 2 million people watch Super Chef. And we see that's going to be our state 4. In state 4, 10% of 20, so 2 million people watch Super Chef. That means it's going to be state 4. Bobby has a square frame called a quadrat. Each side of the quadrat is 1 meter long. Bobby can use the quadrat to estimate the total number of flowers on her lawn. First, Bobby throws the quadrat onto the lawn at random. She then multiplies the number of flowers inside the quadrat by the total number of 1 by 1 meter squares that could fit on the lawn. The diagram shows the size of Bobby's front lawn. When Bobby throws the quadrat onto the lawn, she finds five white flowers inside the quadrat. What is Bobby's estimate of the total number of white flowers on the lawn? So she has this square quadrant. This is the square frame is the quadrat. So the quadrat is 1 meter by 1 meter. When she throws it on at random, she then multiplies the number of flowers inside the quadrat by the number of 1 by 1 meter squares that could fit in the lawn. So, Bobby's front lawn, we need to find its area. The area of Bobby's front lawn is 130 meters squared. The area of a one quadrat, is 1 meter squared. So that means 130 quadrats fit in the lawn. That means if we read this statement again, she multiplies the number of flowers inside the quadrat by the total number of 1 by 1 meter squares that could fit in the lawn. That means she would multiply the number of flowers inside the quadrat by 130, because 130 is the number of quadrats that fit into the lawn. So if she finds 5 white flowers inside the quadrat, that means we do 5 times 130, so 0, 15, 650, to estimate the total number of white flowers on the lawn. Bobby throws the quadrat onto a back lawn and counts 6 white flowers inside the quadrat. Okay, let's think. So 132 white flowers is what she estimates, right? On the back lawn. That means if there are 6 flowers inside the quadrat, she times the number of flowers inside the quadrat by 132 divided by 6, which is 22. She times it by 22 times, right? If each quadrat is 1 meter squared in area, that means the back lawn has an area of 22 meters squared, as it can fit in 22 quadrats, right? That means the area is length times width. So let's look at the areas. This is 10 meters squared. This is 20 meters squared. This is 44 meters squared. This is 22 meters squared. That means the rectangle can be C. The diagram shows the size of Bobby's friend's lawn. Bobby throws a quadrat onto the lawn. There are 3 yellow flowers inside the quadrat. So we need to find how many quadrats can fit into this area. First, we need to break this up into 2 rectangles. So let me draw in different colors. This is going to be our first rectangle, and then this is going to be our second rectangle. So let's look at the blue rectangle first. The blue rectangle, remember area is length times width. The blue rectangle has a length of 8 and a width of 2. So it's 16 meters squared. Area of the green one is length times width. The length, so this overall length is 6 meters. But remember, 2 of it is cut off because we're only looking at this side. We're only looking at this length, right? If 2 meters are cut off from 6 meters, that means the length is now 4 meters. The width is 4 meters, so we have 16. So that means the total area is 32 meters. 32 meters squared. That means we can fit in 32 quadrats, as each quadrat has 1 meter squared area. If there are 3 yellow flowers inside the quadrat and we can fit in 32 quadrats, that means our estimate is going to be 3 times 32, which is 96. In a soccer competition, there are 6 teams. Only 2 games are played each week. Samira has circled the winning team from the first 3 weeks of the season. A team always defeats teams worse than themselves, and always loses against teams better than themselves. None of the 6 teams are equally as good. Which one of the following results will not occur? So let's think. So we have the dibblers are better than the numbats. Dibblers. So we'll do left. If they're here, they're better. So we'll do like a number line kind of thing. Here is better. Here is worse. So we have bibblers, numbats, right? So the numbats are better than the woilies, as they beat the woilies here. And then let's write it out again, but bigger. So if they're on the left, they're really good. If they're towards the right, they're getting worse. So we have dibblers are better than numbats. Numbats are better than woilies. Woilies are better than cockers, right? And marlers are better than dibblers. And then the chuddiches are better than the marlers. Then we have chuddiches which are better. So the Chuddiches are better than the Marlers as they beat them. The Marlers are better than the Dibblers as they beat them. The Dibblers are better than the Numbats. The Numbats are better than the Woylies. The Woylies are better than the Cockers. And of course, Marlers would be better than Cockers. Let's see. Chuddiches defeat Dibblers. This result would occur as the Chuddiches are better than the Dibblers. The Numbats defeat the Cockers. The Numbats are here. The Cockers are here. So that means the Numbats will defeat the Cockers. The Woylies defeat the Dibblers. Woylies are here, but Dibblers are to the left. Dibblers are better than Woylies. Dibblers are better than Woylies. That means the Woylies cannot defeat the Dibblers, so this is the result that would not occur. A new team, the Booties, join the league. The Booties defeat the Quackers and the Numbats. That means the Booties are here, right? Because they're better than the Numbats, they're better than the Quackers, but we don't know if they're better than these three teams. That means we have to assume that they're worse. So we assume the Booties goes here. That means they have to be better than the Woylies already, because the Numbats are better than the Woylies and the Booties are better than the Numbats. That means they are sure to defeat the Woylies. Using artificial intelligence (AI), computers can learn how to recognize objects in photos. One AI system was designed to determine whether cars were present in photos. The table shows the results of the three tests. In test 1, how many photos was AI reporting incorrect? Let's see. Did the photo have a car? Yes. Did the computer report a car in the photo? No. So that means 22 were reported incorrectly. So 12 of these photos showed no car, but the computer reported that there were a car. That means another 12 were reported incorrectly. That means in total 34 were reported incorrectly. In which test was the AI's reporting on photos without cars least accurate? All right, let's see. In test 1, 12 were accurate. In test 1, 12 were inaccurate, 42 were accurate. That means 12 out of, in total, 54 were inaccurate. Okay? Or we can just see which has the lowest accuracy rate, right? The accuracy rate in test 1 is 42 over 54. Because there are 54 total photos which show no car, and there are 42 which show a car, right? So 42 is accurate. Then let's look at this. We have in total 68 which show no car, and 46 of them are accurate. In test 3, we have in total 128 and 104 are accurate. Alright, let's simplify this down. This would be, if we divide both the numerator and the denominator by 7, if we divide both the numerator and the denominator by 6, we get 9 over 7. Here, if we divide both the numerator and the denominator by 2, we get 23 over 34. If we divide the numerator and the denominator by 4, here, we get 32, and then our numerator would be 26. And if we divide again, we get 13 over 16. That means the least accurate, we have to see which is the lowest amount, right? Alright, let's look at our options. Test 1 and test 3 are equally as accurate. 7 over 9 does not equal 13 over 16. They're not equivalent fractions, right? That means C is wrong. Test 2 and test 3, are they equally accurate? No, because 23 over 34 is not the same as 13 over 16. We get rid of this. So now we have to realize which one is smaller, 23 over 34 or 13 over 16. If we think of these as pizzas, right, with 16 slices here and 34 slices here, right? There are only 3 slices left that aren't included. Here, we have another 11 slices left. That means 23 over 34 is a smaller fraction than 13 over 16, right? 13 over 16 is really close to being one whole pizza. 23 over 34 is not even close to being one whole pizza. That means test 2 must be less accurate than test 3. So our option is A. A veterinarian uses a type of pill to treat different animals for an illness. The table below shows how many pills that different types of animals need per day. For example, each cat needs 1 pill, plus 1.5 pills for every kilogram that it weighs. So a 5 kilogram cat will need 1 pill and then 1.5 pills for every kilogram, right? And if it's 5 kilograms, we times 1.5 by every kilogram. So Rose has a 4 kilo cat and a 4 kilo small dog, right? So let's look. The cat will require 1 plus 4 times 1.5, right? Because it needs 1 pill no matter what, and 1.5 per kilo. That means this is 1 plus 6, so the cat needs 7 pills. Let's look at the dog. The dog needs 2 pills, right? 2 pills, and then 2 per kilogram. The dog weighs 2 kilograms, that's 2 plus 2 times 4. So you get 2 plus 8. So in the end, we get 10 pills for the dog, 7 pills for the cat. So in total, she needs 17. Yasmin has a 5 kilo small dog that needs treatment, right? So that means to get the number of pills, we have to add 2 at the start and then 2 per kilogram, so 2 times 5. So we get 2 plus 10, so we get 12 pills. That means a bottle of 60 pills, if the small dog needs 12 pills per day and she has 60 pills, that means she can survive 60 divided 12, so 5 days. Piper has a 6 kilo pet that needs 10 pills per day, right? So let's think, if the pet is 6 kilos, right? Let's think, can it be a large dog? A 6 kilo large dog will need 3 plus 2 times 6. So 15 pills per day, right? Because you have to add 3 and then there is 2 kilograms per kilo. Let's look at a small dog. So we now know since large dog needs 15 pills, but Piper's mystery pet needs 10, it can't be a large dog. Let's look at a small dog. A small dog has 2 pills and then needs 2 per kilogram. So it's 2 plus 12, so 14. That means it can't be a small dog. Let's look at a rabbit. The rabbit needs 0.5, right? 0.5 up front, and then 0.5 per kilogram. So 0.5 plus 0.5 times 6, which is 3 plus 0.5. So 3.5 pills. That means it can't be a rabbit. Now let's look at a cat. So of course, by process of elimination, it has to be cat. But for the sake of completion, let's look. A cat needs 1 pill and then 1.5 times every kilo. So if it's a 6 kilo cat, it needs 1.5 times 6. So you get 1 plus 9, which is 10. That means it has to be a cat. All right. So that's it for the GATE quantitative reasoning section. I'll see you guys for the other section. And just keep in mind, here at Everest, we'll teach you all of these topics and more so that you're ready for your GATE and then even further, you're ready for high school. All right. Goodbye for now.
Thank you for watching. Please like and subscribe for more videos like this from Everest Tutoring.